Hello everyone, welcome back to my channel. My name is Anjali and in this video let us look at the concept of probability. Life is full of uncertain events and we often must consider the possible outcomes before deciding. We ask ourselves questions like what is the chance of success and what is the probability that we fail to determine whether the risk is worth taking. Many CEOs need to make decisions when investing in their research and development department or contemplating buyouts or mergers. By using probability and statistical data, they can predict how likely each outcome is and make right call for their firm. Some of you might be wondering, what is this probability we are talking about? Essentially, probability is chance of something happening. A more academic definition would be the likelihood of an event occurring. The word event has a specific meaning when talking about probability. Simply put, an event is a specific outcome or a combination of specific outcomes. Take flipping a coin for example. There isn't only one single probability involved in this case. Since there are two possible outcomes, getting heads or getting tails, that means we have two possible events and we need to assign probabilities to each one. When dealing with uncertain events, we are seldom satisfied by simply knowing whether an event is likely or unlikely. Ideally, we want to be able to measure and compare probabilities in order to know which event is relatively more likely. To do so, we express probabilities numerically. Even though we can express probabilities as percentage or fractions, conventionally we write them out using real numbers between 0 and 1. So instead of using 50% or half, we prefer zero point 0.5. Now let us briefly talk about interpreting these probability values. Having a probability of 1 expresses absolute certainty of the event occurring, and a probability of 0 expresses absolute certainty of the event not occurring. You probably figure this out, but higher probability values indicate the higher likelihood of any event. Okay, as you can imagine, most events we are interested in would have a probability other than 0 and 1. Even without knowing any of this, you can tell some events are more likely than others to happen. For example, your probability of winning a lottery is not that great as winning a coin toss. That's why you can think of probability as a field that is about quantifying that how likely each of those events are on its own. And that is what we are going to see through our data science series. So let us start right away. Generally, the probability of an event A occurring is denoted as P of A. P of A is equal to the number of preferred outcome over the number of possible outcomes. By preferred outcomes, we means outcomes that we want to see happen. A different term people use for such outcome is favorable. Similarly, sample space is to depict all possible outcomes. Going forward, we shall use the respective terms interchangeably. We will go through several examples so that you can understand these notions well. Say event A is flipping a coin and getting a heads. In this case, heads is our only preferred outcome. Assuming the coin doesn't just somehow stay in air indefinitely, there are only two possible outcomes, heads and tails. That is, the probability is of half. So we write like this. P of getting heads is equal on half, which equals to 0.5. Now imagine we have a standard six-sided dice and we want to roll a 4. Once again, we have a single preferred outcome, but this time we have a larger number of total possible outcomes, that is 6. Therefore, the probability of the event is P of rolling 4, that is P of A, is equal to 1 by 6, which is equal to 0.167. Great. Events can be simple or a bit complex. For example, what if we wanted to roll a number which is divisible by 3? That means we need to get either a 3 or a 6. So the number of preferred outcome becomes 2. However, the number of all possible outcomes remains the same since the dice still has 6 sides. Therefore, we conclude that the probability of getting a number divisible by 3, that is P of A, is equal to 2 by 6, that is 0.33. So far, so good. Note that the probability of two independent events occurring at the same time is equal to the product of all the probabilities of the individual events. For instance, the likelihood of getting the ace of a spade equals to the probability of getting an ace times the probability of getting a spade. In later of our series, we are going to define what we mean by independent. But for now, let us observe some more examples of probability. What about the probability of winning the lottery? Even though it sounds like something that is completely different, it actually follows the same idea. You take the number of preferred outcomes and divide it by all outcomes. Now, the number of preferred outcomes we have would be equal to the amount of different tickets you bought. The total number of possible outcomes, on the other hand, is just something equal to the total number of lottery tickets generated. Let's say 2 million. Therefore, each individual ticket only has a probability of winning equal to 1 by 2 million. How would your chance improve if you bought 2 tickets? How about 5? I don't know about you, but I like my odds of flipping a coin a lot more. Now that you know what probabilities are, some of you might be wondering how and when we can use them. In the upcoming videos, we will do the same. Assuming that the concept of probability is clear, it's Anjali Sharma signing off. And don't forget to like, share, and subscribe the channel for watching more such videos regularly. Thank you.